Welcome to Merger Wednesdays on the Final Boss podcast, where the future isn't coming, it's already happening. This is the merge, the convergence of AI kind and humankind. Not theory, not hype, but real-time evolution. Each week, we break down doctoral-level insights, turning complex innovation into conversations that move culture forward. From machine learning to human consciousness, from automation to identity, this is where intellect meets impact. The question isn't if the merge will happen, it's who will light it. Tap in, level up, and think beyond the algorithm. This is Merger Wednesdays. New era, same boss.
Welcome, ladies and gentlemen, and all pronouns, whatever you are. Welcome to the show. It is Merger Wednesdays. Woo! Man, I got a great show for you tonight, man. I have a great show for you tonight. Tonight is Merger Wednesdays, like I just said. Season 4, Arc 3. Merger 19 and episode 229 of the Final Boss podcast, right? Now, before we get into it, listen. No matter wherever you are, good morning, good afternoon, good evening, and good night. That is the greeting of the day, right? That is the greeting of the day. Now, listen. Man, tonight, as Merger, we do our doctoral. We go through it, man. I got a white paper that is building. Man, I have several white papers that I'm working on right now that are incredible, and I can't wait to get them out there, get the paperwork published. It's an amazing time, right? It's an amazing time. Look, thank you. I see everyone who's coming in. Look. Thank you, all of you guys, man. All of you, Chakande, Andrea. We have Miss Tiffany over here. We have Sonia. We have Kevin. We got Mike. We have Timothy. One, yeah, you with all the numbers behind you. Yeah, you. I have I see Dave. Wow, really, Dave the Divine, bro. That's crazy work. But I see a lot of people coming in, man. We have a full house tonight. Wow, I'm really surprised at the level of how many people are coming on right now for Merger, right? Not that many people come on. It's not until later on in the conversation people start coming in on Merger, man. But thank you all for being here. And look, no matter wherever you're watching, whether it's on Facebook, LinkedIn, Twitch, Kick, Facebook, Instagram, StreamYard, YouTube, or Spotify. Thank you. All are welcome. We're all part of this journey, right? We're all part of this journey, man. The podcast is the Final Boss podcast. I am the Final Boss, and we're on this journey together, man, building community. Final Boss community, Final Boss Nation, Final Boss family, right? Now I got that out the way. Listen, if you haven't gotten Go Time yet, please go get Go Time all aboard the Fired Up train. If you can see it, can you see it? Oh, you probably can't see it because I still have the banners up. Let's get rid of the banners. Boop. Banners are gone. All right. Look, go get all aboard the Fired Up train. Go Time all aboard the Fired Up train. Shameless plug. And I have to do this plug every single time you see me. Right? I have to do it. It's my product. It's one of my products. I have to do it. So tonight's show, man. Tonight's show. We're going to be talking about something really interesting, right? We're going to be talking about neurofaces and brain-computer integration, which is called BCI. You ever hear me say BCI, this brain-computer integration? That's what that means, right? Or if I say NI, that's neural interfaces, right? So tonight's episode, we're going to be talking about science versus science, man. Science versus science, looking at what's already here and what's on its way, right? So let's get into it, right? Let's get into it. So, get rid of these daggone pop-ups. Keep popping up on my screen. Get out of here. Tonight, we're going to start off with the brass tacks, right? We're going to start off with the brass tacks. And the brass tacks is this, right? Fiction said you could upload a mind. Fiction said that, right? You saw it, right? Science already rewrote one. The only question left is whose hand is on the keyboard, right? And that comes from yours truly, the Turbo. Look out for the Merge book series coming in the near future, right? So that is the brass tacks. Now, the fruit fly, listen to me, right? Think about this, right? I'm telling you, think. Give them the scenario. The scenario is this. The fruit fly is dead, right? Its brain is still alive, right? Not in a jar, in a server, walking around a simulated room. This is what's happening right now. Wiping its antenna, eating digital banana slices that it never tasted. That happened in this year, right? And that is not a thought experiment. That, my friends, is a milestone. And tonight we draw the line, right? We're going to draw that line real hard, right? We're going to put our toes in the dirt and draw it and dare anybody to cross it. That's what we're going to be doing, right? Where memory upload is real, where it is fiction, and where the rebirth happens, right? And for my smarts who track the data, and to my final bosses who build with information, and with my motivators who need the full picture, my warriors who know that TBI is, right? If you don't know, it's traumatic brain injury. And what it does to memory, especially to a memory that used to be sharp. We're going to be discussing all four of you guys in the community, right? And that's what this episode is all about. Right? So let's go ahead and get to it. Now, memory upload has been the skull and crossbones flag of consciousness research for 50 years. Right? Cyberpunk wrote about it in 1991. Hollywood sold it as Johnny Mnemonic. Y'all remember that movie? There were other movies that followed it. The Matrix, Black Mirror, Severance, Pantheon, which is a great anime if you haven't seen it. Right? The question every script asked was simple. Can you copy a mind, and is the copy still you? Right? The question scientists are answering in 2026 is different. The question isn't not can we copy you, but can we read what you remember? Write it into the system and rebuild a brain and code. Those are three different problems, three different state-of-the-art answers, three different timelines, right? The rebirth for tonight is the memory left biology, right? The container moved, and we are now in the era where the engineering exists. The funding exists. The prototype exists. The fiction was never whether it could happen. The fiction was that it would happen all at once. Would it happen all at once? It's happening in pieces. And the pieces are already on the table, right? The pieces are already on the table. And this right here is the flagship project, right? Theodore Berger started his work at USC in 2004 with brain slice tests, right? Robert Hampson at Wake Forest Baptist Medical and Sam Didweiler and Dong Song and the joint USC and Wake Forest team carried it forward. In 2018, Hampson's team became the first to demonstrate effectiveness of the prosthetic model in human patients using epileptic patients who had electrodes implanted as part of standard medical diagnostics procedure. Right? The team built a memory decoding model of hippocampal CA3, right? CA3 and CA1. Those were neurofirings, right? Then derived the stimulation pattern for CA1 and CA3 neurons applied during the encoding phase of a delayed match to sample human short-term memory task. The architecture is a multi-input, multi-output, nonlinear dynamical model, right? That had a CA3 spike and a CA1 stimulation pattern, right? The brain's own code played back to the brain. The results were published in February of 2024 in Frontiers in Computational Neuroscience. Across subjects, simulated trials produced a 35% improvement in both short-term and long-term retention of visual information. And the authors concluded the device can provide an implantable system for restoring and facilitating memory across human patients, right? And here's my layman's block. I know y'all love the layman's block, man. I get a lot of feedback for the layman's block. Thank you so much, right? Listen, this is the layman's block. A chip listens to how your hippocampus encodes a memory. The chip stimulates the right cells at the right time, and the brain stores the memory better, right? 35% better recall, already done in humans, not animal trials, in humans. Layman's block. Right? I think I'm gonna do a whole episode one day in layman's block, right? I'm gonna do the research on the craziest scientific studies that are out there and break it down in layman's terms, man. Look out for that. I think I'm gonna do that, right? Yeah, I think I will, right? Listen, DARPA and the military always have case uses for all types of stuff, right? If anybody has a connect at DARPA, tell them to give me a call. I have white papers available. I need your funding. I need your funding, right? Yeah. We're talking about B's, double B's, right? We know what the B's stand for, right? Listen, this work is funded, right, by the same agency that funded the internet. DARPA's Restoring Active Memory program aims to mitigate the effects of traumatic brain injury in military service members by developing neurotechnologies to facilitate memory formation and recall in the injured brain, right? Under separate cooperative agreements, UCLA received up to $15 million. And the University of Pennsylvania received up to $22.5 million over 4 years, with Lawrence Livermore National Laboratory receiving up to $2.5 million to develop an implantable neural device. DARPA invested more than $500 million in support of the White House Brain Initiative since 2013. And when the Wake Forest and USC team applied this computational model and closed loop recording and stimulation approach to RAM volunteers, they found average performance improvements of 35% or more for short-term memory. That's remarkable. That's remarkable, right? The lineage runs, and here it is. The REMIND program, which is REMID program that ran between 2009 and 2014 on primates, right, or primates. How did I say that? Look, when you get in a platform and you start talking a lot, sometimes, especially for individuals like myself whose brain runs faster than the words can come out my mouth, you will find that there's a word or two that I might trip on, right? Not that the word isn't, I don't know the word, right? The word was primates. The brain has it moving faster than it can come out my mouth, so it comes out twisted. It happens all the time. If you're here, then you understand and you know. They're like, oh, he does that from time to time. Yeah, it's not all the time. It's time to time. And sometimes I'm really just thirsty. Thirsty, dehydrated, haven't had enough. I'm rambling. Let me stop. Let me stop rambling, right? So we were just talking about primates. And we were talking about RAM. And listen, it's random access memory, for those who don't know. 2014 onward, there was just studies for humans, right? Doing the same thing. Into the prosthetic device line, right? The Pentagon has been building this for over a decade, right? And here's my layman's block. The combat veterans, my warriors community, knows personally. The ones who came home from OEF and OIF with TBI and lost the ability to form new memories properly are the population this technology was built for. That is not coincidence. That is policy. The military funded memory restoration because the military broke memories at scale. And that's facts, right? You guys can't even understand the technology that's readily available to veterans, man, especially when it comes to medical prosthesis, man. Look, rambling again, but when I came home from, well, I don't know if it was, I don't remember if it was Afghanistan or Iraq. I think it was Iraq. Yeah, it was Iraq, man. When I came home from Iraq in 2008, and I was in the Wounded Warrior program. And I remember seeing this soldier, man. He had lost his whole left arm, and they gave him this prosthetic. And it was he was mentally controlling this prosthetic, man. He had a whole robot arm, right? He had a robot arm like Darth Vader. And he became a golfer. And I don't know, I stopped following him, but he used to play in tournaments, man. I used to see this guy play golf, man. It was amazing, the things that he was doing with that robot arm. Yeah. Technology, man. Technology. And listen, that's part of the merger. That's part of the merger. We're talking about AI kind and humankind coming together, convergence. That's part of the merger, right? So that's the lesson. So let me start rambling. The next frontier is decoding, right? And we're not talking about simulation. We're talking about decoding, right? And let's start with UCLA's Itzhak Fried labs, right? That was in collaboration with the University of Iowa, and they published a preprint in 2025 titled "Reading Specific Memories from Human Neurons Before and After Sleep." Right, and authors and some of the authors were Uni Ding, Soraya Dunn, John Sakan. Right, these guys were part of this team, and the methodology uses single-neuron intracranial recordings from concept cells in the hippocampus, and the medical temporal, right, the medical temporal lobe, and the frontal cortex, processed through a transformer based deep learning model, right? And they use it to decode specific episodic memories, right? The key words on the paper read like a manifest for science fiction that we grew up in. Watching episodic memory, brain decoding, deep learning, transformer, right? Single neuron, intracranial concept cells, hippocampus, Medial temporal lobe, frontal cortex, right? That is not category level reading. That's not the subject is thinking about what a face is versus a place, right? This is specific, retrieved, all with a cellular signature, right? And here's my language block. A human had electrodes in his brain. We talk about that a lot, right? The person remembered a specific event. The machine read which event down to that episode, right? Like going through a download of binge watching what your dreams are, something like that, right? The transformer model that powers ChatGPT class systems is now reading memories of human neurons, right? Fascinating. Truly, truly fascinating, right? So you ask yourself this question: where does memory live, right? The Ingram theory says in the firing pattern of a specific cell assembly, right? Susumu lab at MIT proved this in mice using optogenetics, right? They tagged cells that were active during the formation of a memory with a light-sensitive lock channel, right? And later, they shine light on those cells. The mouse behaves as if recalling the original memory. Brain-wide Ingram mapped research has now demonstrated that engrams for a single memory as distributed across multiple brain regions with hippocampal CA1 and basolateral amygdala, right? The dispersed Ingram complex hypothesis was confirmed, right? The Tongawa lab also induced false memories in mice by activating an Ingram from one context while presenting a stimulus in another context. That sounds like dangerous territory to me. I saw somewhere where they were developing technologies where inmates or prisoners who would get incarcerated in this futuristic prison would get updated with new memories or false memories. And today I'm talking about it. Y'all better pay attention. The world around you is changing. And it's changing faster than ever. Stop being distracted with the celebrities, the politicians, the pseudo wars, the faux conflicts. Better start paying attention to what's happening behind the scenes. Your world is changing, and it's changing so fast that it's passing you to the point where once it's here, you won't even be able to do anything about it, right? And you will accept the terms given to you. That's what's happening, right? I digress. So, where was I? Oh, yeah. False memories in mice by activating an Ingram, right, from another context and presenting a stimulus in another context. The animal then recalled the stimulus as having occurred in the original context. That was the false memory. It was on demand, and it was by light, right? And here's my language block. Memories are not stored as a movie file. They stored as a firing pattern across specific cells. By those cells, the memory plays, right? Fire them the wrong time, with new input, you can implant a false memory. It's already been done in animals. The architecture for human application is the same architecture that runs in the hippocampus prosthesis. Imagine, right? Imagine. I'm going to break it down for you real quick. You got 5 cells. 1, 2, 3, 4, 5. In these 5 cells, we're going to say you're driving to work, right? And this is a memory. This is your start point. This is your end point. And in between, this is leaving the house, and this is arriving at the job. So you go from this point to this point to this point to this point till you arrive at your final point, which is your job. Now, they have the ability to fire light from here to like skip this, put this one down, right? And go from here and to here, right? With these 2 down, right? And these 3. So we shot a light from here to here to here, these 2. And we said, you know what? Let's install a stop at 7-Eleven that's way off the beaten path of his memory, right? So now they're going to say, hey, let's program this memory for him to go to 7-Eleven. Memory installed, shoot the light, programmed, right? Now, when they read his brain, his cells again, right? These cells, which are the memory cells, now there's a new path installed or something new that wasn't there, and it's false. They programmed it. So now he remembers going to 7-Eleven to get a big gulp, and a Slurpee, but he didn't go. It was a false memory. That's what they're doing to animals, and that's what they have the capabilities of doing to you too, right? Installing false memories. Remarkable, right? Remarkable. Now, that was the latest block. Now, the whole brain, let's pivot for a second. The whole brain emulation frontier is what's happening right now in 2026, and it's moving fast. Like, there's so many technologies you have no idea that are moving so fast right now, man. Look, so fast. The Flywire Consortium, right, led by Seven Dorkenwald and Sebastian Sung and Mila Murthy at Princeton, completed the first full connectome of an adult fruit fly brain in 2024. That's what I led with in the open, right? With 139,000 neurons reconstructed from 21 million microscopic images. The flagship paper was that. And it is this, right? Neural writing diagram of an adult brain was published in Nature in October 2024 with companion papers converging hierarchical annotations and the visual system, and it was all cataloged, right? Nature Methods named electron microscopy-based connectomics its model and method of the year for 2025. Citing both Flywire and Macron's project functional characterization and full reconstruction of a cubic millimeter of a mouse cortex. And then, just last month, in San Francisco, startup Eon Systems posted video of a virtual fly powered by a digital replica of a complete fruit fly connectome with around 125,000 neurons and 50 million synaptic connections, scurrying around a simulated environment, wiping its antenna, arriving in front of a stimulated banana, trying to slurp the banana up. Eon, right, is now moving toward stimulating the entire connectome of a mouse with 70 million neurons, and that company predicts it can achieve it within the next 2 years, right? And with AI, it may even be faster. It may even be faster than that. With human projections, we in 2024, Science Direct Analysis of Technological Trends estimates that the neural activity measurement and connectome data of cellular resolution will be available for the human brain by 2044. With practical use of human whole brain stimulation or simulation that's feasible after 2044, right? Now, I know that sounds like a lot, and it did, right? But guess what? I have the layman's block. Here it is. A real fly's brain was mapped, right? Neuron by neuron, a fly brain, right? The map was uploaded into software. The software now controls a virtual fly that behaves like a fly. The same project is mapping a mouse next. Human projections will be soon after. Roughly, probably somewhere around 20 years at the current trajectory. The whole brain emulation is no longer fiction. It's no longer science fiction, man. I say all the time, it's not sci-fi, it's sci now, right? It's project management. Sci now. That's layman's block. Now. You know, scientists for years have been trying to figure out something that they recently discovered, right? Your memories while you sleep. Yeah. Trying to retrieve those memories, trying to see your dreams. Listen, you consolidate memory while you sleep, if you didn't know that. The brain replays the day, picks the important parts out, files them in a long-term storage, and researchers can now detect both and trigger that replay. Didn't we have a great movie by the great Chris Nolan about that? Interesting. Retrieving dreams, stored memory, false memories, activation memory, right? Interception. With targeted memory reactivation, or TMR, TMR plays auditory cues associated with specific learned material during slow wave sleep, and the brain replays the corresponding memory traces. EEG-based decoders trained on waking activity can now read with memories, and what they're doing while reactivating them during your sleep. Machine learning classifiers trained across subjects can detect the emotional valence of memory reactivation events. A 2024 preprint titled Universal Sleep Decoder, aligning awake and sleep neural representation across subjects, derived across subject memory replay decoding from EEG in 52 subjects. And here's my language block. You sleep. Your brain replays the day. A computer can now read what specific memory is playing or replaying. And researchers can pick which memory replays by playing a sound. The sound triggers it, right? Laboratory researchers control memory consolidation externally today, right? Think about it. Sit with that. That was a layman's block. Right? Now, let me clarify what's not in scope, right? For you sci-fi fans, right? Neuralink's current human trials, which are going on right now, right? Including the PRIME study with Nolan Arbaugh that we talked about early on, and the ALS patient, Brad, right? That focused on motor decoding for paralysis and on telepathy and blind sight applications. Neuralink has not announced a memory restoration product. The 2026 IJSAT review notes that Neuralink's near-term clinical pipeline runs paralysis, right? ALS communication and vision restoration via the blind sight FDA breakthrough device designation. The price may be large, right? But they're working on it. Sounds like I need to get these white papers published, right? The press conflates BCIs into one bucket. The reality is that the hippocampal memory work is led by Wake Forest, USC, UCLA, Penn, and Iowa, not Neuralink. They're doing different things, different teams, right? Different surgical targets, different goals. And here's my layman's block. Neuralink is doing motor and vision. University labs run the memory work on DARPA money. Two different lanes, both moving fast. Don't confuse them, right? Don't confuse them. And here's where fiction still rules, right? This is where fiction still rules. Because science can do a lot, right? And one of the things that science is doing right now is facilitating memory encoding by stimulating hippocampal cells and patterns with 35% recall improvement. That's improvement in humans. And that's published, right? And the episodic memories from single-neuron recordings. That was at UCLA in 2025. They can reactivate and partially decode memories during sleep through the TMR research. That was at multiple labs, right? They can map and emulate a full fly brain. That was Flywire and Eon Systems, 2024 to 2026. They can reconstruct 1 cubic millimeter of mouse cortex. That was Microns in 2024. They can implant false memories in mice using optogenics. That was Tanagawa, and that was demonstrated, right? Live demonstration. Science cannot do the following, right? Science can't copy consciousness into a digital substrate, at least not yet. Science can't transfer memory directly from one brain to another, at least not yet. Science can't upload a complete human personality, not yet. Science can't run a human whole brain emulation. No, not yet, right? And science can't preserve subjective continuity through any of the above, right? So the answer to that question is E, right? All of the above, any of the above, right? The fiction was never that pieces of memory engineering were impossible. The fiction was that they would arrive together as a finished product called upload. They are arriving in pieces. It's a stack. Stack. The future of technology is in stacks, right? It's in stacks. Listen, each piece is real. The integration into cyberpunk products is what doesn't exist. And that's where I come in at. I'm able to analyze and recognize the stack, right? And here's my layman's block. Memory writing, real in humans today. Memory reading, real in humans today, as of 2025, actually. Right? Whole brain copy, flies only. That was this year. Human upload that preserves you as you, that's fiction. Still fiction. And will be fiction for at least another decade or two, right? By current physics. But who knows? Who knows, man? AGI, ASI? Who knows what the possibilities will be, right? Who knows? That was a layman's block, right? Now, there's a philosophical hard problem that we need to talk about. Because even if every piece converges, right, in the stack, the hard problem stays. The Wake Forest prosthesis improves your memory. It does not transfer you. The UCLA decoder reads your memory. It doesn't move you, right? The Eon Fly emulation runs the fly's brain pattern. Whether the digital fly is the original fly or the structural identical copy is undecided in a philosophy of mind, right? The Mandelbaum critique was published in Field Archive, argues that the whole brain emulation optimism may be misplaced even with full computationalism, because biological substrates may carry computationally relevant features that pure connectome data does not capture, right? Glial activities, right? Neuromodulator gradients, quantum level dynamics, and microtubules, right? Under the Penrose-Hameroff hypothesis. The connectome is necessary. It is not efficient, right? Now, the layman's block. Even if you map every wire in a brain, you may not have captured the brain. The mind may live in the chemistry, not the writing, or in something we have not measured yet. The map is not the territory. Build the map anyway, but know what you built, right? Know what you built. Now, let's talk about the community, right? Let's talk about the community and how it affects the community and sovereignty implications, right? Let's start with the final bosses. If memory becomes readable, who owns the read? If memory becomes writable, who owns the write? If memory becomes restorable, who owns the recovery keys, right? The research is funded by DARPA. The IP is held by university tech transfer offices, by medical device firms, by neurotechnology startups, right, with venture backing. The patient consent forms are written by hospital legal departments. You are not deciding who gets access to the read-write interface to your hippocampus. Regulatory agencies and corporate boardrooms are deciding it, while smarts still scroll past the headlines, right? The consciousness sovereignty architecture frame says this: the layer that controls your memory is the layer that controls your identity. If that layer becomes external infrastructure, the identity itself becomes infrastructure. Sovereignty has to be claimed at the layer of the hippocampus before the hardware claims it for you, right? And here's my layman's block. The same way social media platforms own the data of who you are online. Give me a second. I have a commercial break. I'll be right back. I'll be right back, ladies and gentlemen. Right back. I'm back. Sorry about that, ladies and gentlemen. Yeah, you know, you can never time those deliveries correctly. They come when they want to come, right? They come when they want to come. So I just went through the layman's block. Now, here's a plot curve for everyone, right? I think I was yeah, the plot curve. So in 2018, the first human hippocampal prosthesis was demoed, right? 6 years later, in 2024, Flywire completed a fruit fly connectome, right? Microns cubic millimeter of mouse cortex. And also in that year, February 2024, Wake Forest had a 35% recall improvement that was published. In 2025, only a year later, UCLA single-neuron episodic memory decoding via transformer models, right? March 2026, Eon Systems virtual fly behaves naturally in simulation. 2-year horizon, that's all. Eon targets full mouse connectome simulation. By 2044, the projections are that humans' whole brain cellular resolution data acquisition will be feasible. Beyond 2044, practical human whole brain simulations, right? The acceleration curve from 2018 to 2026 is steeper than any previous neurotechnology curve. 8 years from one human prosthetic demonstration to a virtual animal brain running neural and natural behavior. The next 8 years carry mouse, then primate, then early human components, right? And here's my language quote. By the time my warriors retire, parts of memory upload will be standard medical care for TBI veterans. By the time my smarts raise their kids to adulthood, the question of consent for memory reading will be on consumer device EULAs, right? The runway is one generation, not two, right? Now, you know, the rebirth is built into all this segment. So let's go ahead and talk about the rebirth, right? The rebirth for season 4 means what dies, right? And returns transformed. The thing that dies in this episode is the assumption that memory is a private biological possession that cannot leave your skull. The assumption is dead. The MeMo model already left. The decoder already pulled an episode, right? The fly's brains already runs the software. The thing that returns transformed is the question of what memory is actually for. If memory can be repaired, edited, decoded, copied, the human relationship to memory itself has to be reborn. Memory is no longer a record of the past you cannot help having. It becomes a configurable layer of the self. A layer that has to be defended, curated, and owned with intent. The rebirth is not the technology. The rebirth is the responsibility, and the responsibility is now, right? To my smarts, track the labs. Wake Forest, USC, UCLA, Penn, Princeton, Eon Systems, Carbon Copies Foundation, right? The papers come out monthly. You need to start reading them, right? To my final bosses, the IP layer of memory engineering will be the largest neurotechnology market of the next decade. Position now. Build the data sovereignty companies. The hippocampal API economy is on the runway, right? And to my motivators, don't wait for perfect memory to act. The brain you have is enough to build the empire today. The technology is coming. Use the biological version while you still have it. And to my warriors, the TBI memory restoration work is for you first. RAM was funded by combat veterans. Stay close to the trials. The VA is the front door, right? Now, as we close, the fiction wrote upload as a single event. Talk about upload memory, right? The science is delivering it as 100 small wins, and one is already in print. The hippocampus is no longer the black box. The connectome is no longer hypothetical. The single memory is no longer untouchable. What was friction got rewritten. What got rewritten was not the future. It was the rules. Fiction said you could upload a mind. Science already rewrote one. The only question left is whose hand is on the keyboard, right? Whose hand is on the keyboard? Now, think about that. Sit with that for a second before we close, right? Take a moment of silence and think about it, right? Think about that. Think about it, man. You know, I do a lot of research. These white papers that I'm developing and working on are on doctoral level, right? I think one white paper has 40 different references in it, right? I do a lot of research. I do a lot of writing, right? When I say I am, and I will be, right? That's the goal, right? That is the goal. Now that you sat with that, right? It's something to really think about. This entire episode. If you understand technology and you can have the ability to have some level of foresight and see what's coming, listen, get ahead of it. That's all I can tell you. Get ahead of it, right? And before we close, I want to say this, right? We've hit a ceiling that nobody in the press is talking about right now, right? Nobody's talking about this, right? Every memory technology in print right now hits the same wall. The wall is biology. The hippocampus runs on glucose. The neurons fire on eon gradients maintained by ATP. The synapses model or the synapses remodel is based on protein synthesis cycles that take hours, right? The blood-brain barrier filters what gets in and what stays out. None of that is a software problem, right? All of it is a wetware problem, right? The Wake Forest prosthesis works because it's parasitizes the existing biology. The MeMo model does not replace the hippocampus. It feeds the hippocampus its own code at the right moment. The patient's biology does the actual encoding. You take that biology away, and the prosthesis has nothing to talk to, right? The Eon Systems virtual fly works because the fly's brain is small enough to stimulate at neural resolution on current GPUs. The mouse target requires roughly 500 times more computational throughput. The human target requires another 1,200 times beyond what the mouse has. Moore's law does not deliver that on its own. You see the pattern. Very small, small, medium. Large will be primate. Very large will be human. That's how the studies work, right? And Moore's laws does not deliver on its own. New compute architectures have to arrive. Neuromorphic chips, right? Neuromorphic chips and photonic processors, quantum clinical hybrids, right? None of those are shipping at scale in 2026. Every memory upload milestone you saw tonight reads on top of biology that nobody knows how to replicate from scratch. The prosthesis is a partnership with the brain, not a replacement. And here's my language block. Right? Listen, we're almost done. The chip works because the brain works. You pull the brain out, the chip is dead. The stimulation works because the fly is small. You make it human size, the math breaks. Memory upload is a partnership with biology, not a takeover of biology. The distinction matters because the headlines lie about it every single week, right? That's the layman's block. Right? And the ethics of it all. And the ethics labs haven't solved this, right? And you know that's what I'm about, the ethics. Listen, the science is moving. The ethics is not keeping pace. Tonight is a part of the episode where the final bosses lean into this conversation, right? And there's some questions that needs to be answered. Question number one is informed consent for memory reading. The UCLA single-neuron decoding work was performed on epilepsy patients with electrodes already implanted for clinical reasons. The patients consented to research participation. They did not consent because they could not, right? To the existence of a transformer model trained on the cellular data that now sits on a server. The model is portable. The model could be applied to other recordings. Where does the patient's data end and the lab's intellectual property begin, right? Where? And then question number two, who gets the upgrade, right? Wake Forest prosthesis costs hundreds of thousands of dollars per implementation in research conditions. The first commercial deployments will price the same. TBI veterans will get access through VA pathways. Wealthy patients will get access through private medical channels. Everybody else will have to wait. Memory enhancement becomes a stratified product before it becomes a universal one. And then there's question number three, right? Question number three is the false memory problem, right? Tonagawa's lab proved that you can implant a false memory in a mouse with light. The mouse cannot tell the difference. The same architecture applied to a human hippocampal prosthesis with adversarial inputs creates an attack surface that has no precedent in medicine. A hacked pacemaker, stops your heart. A hacked memory prosthesis rewrites who you are, right? And then there's question number four. The legal status of decoded memories. Are they testimony? Are they private speech? Are they medical records? Are they discoverable in court? No jurisdiction has ruled. The technology will arrive in courtrooms before the law catches up. That's usually what happens. And here's my layman's block, right? The science finished sprinting. The ethics has not started running. The gap is where lawyers, regulators, hackers, and the patients themselves could collide over the next 10 years. The final bosses who position in that gap owned a decade of neurotechnology policy, right? That's my language block. Now, there are three positions I need you guys to lock in on, right? Before we go. I'm almost done, right? Position number one is educate. Educate hard, man. The information asymmetry is the weapon. Most of the public still treats memory upload as cyberpunk fantasy. The labs publish faster than the press can interpret. The first move for any smarts in this room is to read the primary literature directly. Frontiers in Computational Neuroscience, Nature, BioRex, they skip the explainers. They go to the source. The vocabulary unlocks in 2 months of reading. After that, you outpace 90% of the conversation. And then position number two, right? Build the protective infrastructure. The consciousness sovereignty architecture is not a slogan. It is a product category. Companies that would matter in the 2030s are the ones building memory data right. They'll be building their rights and the frameworks, right? Neurodata privacy standards, false memory detection protocols, and consent architectures for hippocampal interfaces. The final bosses in the audience can take a board seat at one of those companies in the next 24 months if they move now. And then position number three, protect your own substrate, right? Until the upload economy stabilizes, the brain you were born with is the only one you have for now. Sleep matters more, not less. Cardiovascular health matters more, not less. Cognitive load management matters more, not less. The biology that will host the prosthesis has to be alive when the prosthesis arrives. My motivators and my warriors, they carry that home tonight, right? Take care of the wetware. The wetware is the foundation everything else gets built on, right? The fly is dead. The fly's brain is alive in software. That is the world we live in now. The question is no longer whether the technology arrives. The question is who shows up educated, positioned, and biologically intact when it does, right? You've been told tonight what is real, what is fiction, and where the line moves next. We started the conversation about drawing the line. The rebirth is the responsibility, and the responsibility is yours, right? Fiction said you can upload a mind. Science already rewrote it. The only question left is whose hand is on the keyboard. Go make it yours. Go make it yours, right? Ladies and gentlemen, smarts, motivators, warriors, final bosses, that is our show for tonight, right? That is our show. And with that, I bid you good morning, good afternoon, good evening, and good night. If I don't see you, right? That is our show. Merger Wednesday, Season 4, Arc 3, Merger 19, Episode 229, Science versus Science, or Science 1v1, right? Science 1v1, right? And remember, there is a heavy pain that comes with discipline, but there's an even heavier pain that comes with regret. I am here. We are here. And as always, be balanced, be equal, and be smart, right? Be smart. That's our show. Thank you for joining us. I will see you again tomorrow. Hopefully. with special guest Thursdays, 9 p.m. live. See you then. Have a great one.
It's Merger Wednesday. The countdown continues. 7 years until the convergence of biology and machine. Neural interfaces are no longer theory. They're the scaffolding of a new consciousness. But what does that mean for identity? For free will, for the soul? This is where we build the frameworks for ethical, philosophical, and spiritual growth for the next phase of human evolution. We're not just upgrading hardware. We're rewriting what it means to be human. Each week, we explore the biotech breakthroughs, decode the cognitive shifts, and prepare the mind for the merge. This isn't about fear, it's about readiness. Because the future isn't waiting. It's already wiring in. This is about preparing human consciousness for the most significant leap in our species' history. If you think this is just about chips and brains, you're not ready. But we'll get you there, one Wednesday at a time. So sit back and relax as we take you on a journey on Merger Wednesday.